Question 3. We've now moved on to topics of ideal gas processes. So we've got a monatomic ideal gas in a sealed container. It is taken from an initial state I to a final state F through two different paths, A and B is shown. So we've got the initial state down here, final state up here. And we're asked for path A, does the temperature of the gas increase, decrease, or remain the same? Okay, so let's think about the ideal gas law. PV equals N or T, so I can rearrange for T and say that PV equal divided by N or. So for sealed containers, N is constant. So no moles are added or removed. So that means that N and R are also constant. Or it's a constant by definition, sorry. N is a constant, so the product of N and R is constant. So for this, for sealed containers, T is proportional to PV. So in this case, I want to think about if I want to figure out what's happening to the temperature of the gas, I want to determine what happens to how does the initial PV value compare to the final PV value. So I can think of that T initial is 1P and 5E's, so it's 5PV divided by this NR, which is the same throughout. And T final is equal to 5P's and 1V, so the product of PV is the same. So if N is not changing and the PV product is the same, we can conclude that the temperature of the gas is the same. It's not changing. So Ti equals Tf. So this is in a sense, and I guess the question, in a sense, it does designate the path. So I guess as separated from process, but in both cases, in this case, both for along the path A, the temperature of the gas also remains the same. For process, say if I were to consider a process, I definitely know that I and F are the same. But if I wanted to look along path A, this is an isotherm, so the product of PV should be the same along this particular curve. So this is an isothermal process. So I can link. See this? So path A is an isothermal process. PV is a constant along that process. So if it's a sealed container and the PV part does not change, we can conclude that the gas temperature remains the same for the path.